So welcome back to another Inventor tutorial. In this tutorial we're going to look at a design accelerator around gears, shafts and bearings, and basically create a gearbox with an input and output shaft entirely from just using the design accelerator. The only component we'll actually design is the actual case itself, and we'll do that within the assembly process where we create an individual eye part within the assembly. So let's jump on in and see where we end up. So I've come straight into an assembly, and our design accelerators are all found within the design tab along the top here. We're going to be looking at our power transmission design accelerators. We're going to start off with our spur gear. We'll then look at shafts, bearings and parallel splines as well. We'll also look at keyways. So the first thing we want to do is look at our design accelerator for spur gears. So we'll select the spur gear, and immediately it'll ask us if we want to we will have to save the assembly first. So we'll just click OK, and I'm going to save it as design accelerator. And just leave it as an IAM file. That's fine, and I'll click save. I've already got some this has already got dimensions from something I did previously, so yours might look slightly different. For instance, it most probably have a number of teeth. Your desired gear ratio will be different. Various different components will be slightly different, but first of all, we have the design guide. We can design around a module, a number of teeth, a center distance, various different ways of designing our spur gears or our gears. We'll work with number of teeth. The desired gear ratio, mine's currently set at 2.4 to 1, and we're going to be external gears, so the actual gear beside itself. If you wanted to do something like a planetary system, then you'd be looking at internal gears, and you'd have to select the little tick box next to it. We have gear 1 and gear 2, so obviously we're just looking at 2 gears here, and from there we will then we need to create some parameters that we want. So I'm going to go to 3 to 1, or gear ratio 3 to 1, and a center distance from each other is, I'll go 50 mil. If we then click calculate, it actually has the ability to work out if this would work in real life. I'm not going to go into that in too much detail because we have to look at the calculations. We're just going to use it for creating some simple input and output gearbox with a 3 to 1 gear ratio. The face width is the thickness actually of the gear itself, so both of them are the same. That's fine, and there's nothing else that we actually need to change here. So if we click OK, we'll get another pop-up about file naming, and we click OK again. It will tell us that it will design fail, but we're not too worried about that, so we'll just accept that. And we've got our 2 gears there at a 3 to 1 ratio. We'll be able to move them around. You have the ability to basically just place them anywhere in your design, in your assembly, because of course we'll come back in a minute and we'll start doing a whole load of other things to move them to and constrain them to various axes. So I'll just left click and select them, and now they are actually grounded at their current position. And we can work with that. It's not a problem. It's a bit off angle, but if you wanted to, you could turn on your origin planes, and you could see how they're actually already linked in some way to those origin planes, and if you wanted to, you could move them if that was helpful to you. If I just rotate to there, you can see straight away that we've got the gear's been designed and the tooth's been designed, and basically the meshing process has already taken place, but we can't move it because they are grounded. So not hugely complicated. If you wanted to go back and edit it, you could just right click on the tree here and edit using the design accelerator, and then you could edit the various different components that you wanted to. So for instance, you could up the center distance to 60 mil, click OK, accept it, and they've got the center distance has got larger. We could change the gear ratio if we wanted to. So instead of 3:1, we could do 2:1. And then we'll just click OK. And obviously it changes the size of the gearing depending on the gear ratio. And it also updates the number of teeth for that particular gear itself. So we'll leave it at 2:1. So we now need to look at drawing our shafts and creating our two shafts. This is also another design accelerator, and it's in our power transmission, and it's just another section that gives us a pop-up which will look something like this. Now you won't have this because I've already been doing some design acceleration work. You'll have various options, but so what I'm going to do is I'm going to delete all but one of them and discuss each one in turn. So I will do a quick zoom in so that we can then point some things out. We've got three sections that we need to look at. This section, and this section. So what it's showing you is this section is currently here 5 millimeters in diameter and 100 millimeters long. And on the left hand side it's got a chamfer, then it's straight shaft, and then it's got a exact 90-degree end to it. So it's basically what is going on in the front end, the mid section, and at the end of that particular section. And we can build up various different sections to take bearings, to take through into the actual gear itself, and we'll show you how to do that in a second. So each one has its own little drop down. So it's it actually, if you hover over it, it says first edge feature. So chamfer, fillet, lock nut type thing, all sorts of different types of entry into that particular part of the shaft. We then have the different types of center section, so cylinder, cone, polygon, and then we've got our end feature or our exit. This section here is adding keyways and through holes and things like that. We're not going to worry too much about that because part of what we're going to do is create a keyway in the actual in the sort of center boss of the actual gear itself. So I will keep it as a chamfered internal edge, then through straight cylinder section, and then just have an exact no feature finish. To then add another section, or actually first of all I'm going to change the parameters of the 5x100. So I'll just double click on the 5x100 section, and we can now input those data. So for instance, I'm going to go 10 mil for my diameter, and my length down to 50 mil. And you can actually see that it's changing the shape and size of the particular shaft as we input the information in here. And of course you can drag some of these arrows and dots, and it will change the shape independently of putting it in here, but we'll also update it in there as well. So that's our basic input shaft. So we'll click OK. Now we're going to insert a section, insert a cylinder section. We have split sections, cone sections, polygon sections. We're just going to be interested in the cylinder section. So we're going to insert another cylinder section. I'm going to keep it as no feature, cylinder no feature, because this is where I'm going to get the bearing to sit, for instance. Or bearing will butt up against it. So I want it to have a slightly larger diameter, really short in length, so that it's got the bearing's got something to butt up against. I'll do another section now, which is the section that will go through the actual gear itself. So this diameter I'll take to 25. We set the thickness of the gear at 20 mil in our design accelerator. So for this section, I'm going to actually put in 30 mil so that it comes out slightly outside of the gear. And then basically I'm going to reverse these dimensions. So I'll go back down to a 15 by 5. And I will then go to my sort of output shaft of another 10 by 50. So there we have our first shaft. It doesn't look like much, and don't forget as well, if you want to, you can just go back to these and, for instance, on our shelf, our ledge that's going to have the bearing sitting on it, we might want to put a little chamfer at both edges. So distance is 0.5, angle is 45 degrees, and that's going to be fine for what we want. And actually we'll put a chamfer on the outside as well, just because we can, and we'll do the same for this one. So they keep the same features symmetrically. And now all we do is click OK, and it will then file name. It will give us a file name of where it's going to save it to. We'll click OK. And we now have this shaft that we can just place in our assembly, and then we will constrain to our particular object. So we'll do the constraint straight away. So we'll have to go back into our assembly tab, and we're going to constrain the axis of the shaft to the axis of the gear. Now for that we'll need to have our Spur Gear tab on the left hand side, and we'll have to find the origin for not the actual Spur Gear but the actual gear that we're going to be using. So we'll have to look and just see which, so not Spur Gear 1, we'll need Spur Gear 2, the origin, and we'll want, my one will be axis, the Z axis, and we will then marry it up with the axis of the shaft that we've just made. So we'll click apply. Now of course it can move in and out, and it can rotate around that axis, but we want to get it to sit so that the various faces line up. So we'll do another constraint. We'll constrain the face of the gear to the face of the shaft. It'll be flush, but then we need to offset it to make it central. So it should be 10 mil. No, be 5 mil then. And now it sits symmetrically in the middle of that gear. We can apply that, and now what we can do is do exactly the same but for the smaller gear. So we'll design our shaft. Now of course we can virtually use all the same functions, we just need to think about the size of them. So certainly the center one needs to come down in size. It needs to come down to 15 mil. Click OK, and then of course we need to bring some of these down in size as well. So we'll bring that one down to 10 mil. And this one down to 10 mil. And the input and output shaft will bring down to 8 mil. Okay, we'll click OK and then say OK to save. We'll position it and we'll do exactly the same process around our constraints. We'll want spur gear 1 Z axis and the axis of the actual shaft. We'll apply that and then it should just move forwards and backwards, and therefore we're going to have to do the constrain the faces with a flush as our solution, and we'll offset it by 5 and we'll apply and we will cancel that. So we still have a bit of a problem. If I in that there's actually no holes through the gear itself. It's still solid. We need to create that sort of feature, which we'll do now. Turn the visibility off. I don't want to do that. I'll turn the visibility back on, and it was the transparency. So the next part of our design accelerator that we're going to want to do is our keyway. So we'll select our keyway, and we're just going to go with a grooved with round ends. We're creating a new one. We can put in some basic sizes, and there is a whole, and actually it will do a lot of the calculations for you when actually you select the right references and the right hub groove, and I'll just show you what that looks like now. So the first thing is we need to select the cylindrical face of the reference geometry that we want, which is obviously the center section of the shaft. We now need to select the plane or work plane which is the edge of the face of that section in itself. And you can see straight away that it's actually starting to design it already. We just need to put a couple of other bits of reference geometry in there, which is our hub groove, which will be the groove that goes into the actual hub of the gear. So we'll just select that face, and then the next is our circular edge. Our circular edge is showing us the rotation, which direction it's going to rotate. So we'll just use the flat bottom of each of the gears here. I'll zoom in a bit so you can see it. So I'm just going to use that because that's the circumference of the circle basically. We can now use our arrows to drag and adjust the size and position of our keyway, and when we're happy, it's going to basically generate the key, the insert in the shaft groove, and also the insert in the hub or gear, and we'll just click OK. It'll ask me which bits I want to save, so I'll just click OK, and now you can see straight away that it's generated the key. There is, if I make the shaft transparent, you can actually see it's created the cutout in the key, and it's created the slot in the actual gear itself in the hub. So we'll just turn transparency back on, back off, and we'll do exactly the same now with the big gear. So we will put a keyway. We're going to select the reference geometry. So reference 1 is the shaft central hub, then the face edge of that section, then we need the face of the gear, and the rotational axis. Then we can size it accordingly and position it accordingly if it wasn't quite right for us, and we'll just click OK, and then the file naming, just click OK for that, and there we have it already built for us. We'll look at bearings now. So we'll select our bearing, and we can do this several different ways. We can actually specify the minimal required inside diameter and the maximum required inside diameter, and then get the whole thing to search for. So that's what we'll do. I can't remember what that was 8mm, so that was 10mm. So we're going to have the bearings sit up against this face here. So we need 2 bearings of 10mm and 2 bearings of 8mm. So I can do 10mm and 10mm, and then I would change my drop down here from angular contact ball bearings, and I will change it to all ball bearing categories. And then I didn't like that, it needed to, well, I wonder what's going on. All ball bearing categories. And then just select all ball bearing categories there. And it gives us all the different sort of versions of it. And depending on what you particularly need or want, I'm just going to go with a 5898. I think that's a good one for this particular operation. Just click OK. Click OK, yep, and then I'll just plonk a bearing on the end there, and I will then right click on it, copy, and then I'll paste 2 of them. So we can now constrain those. So again, we'll just do axis, will most probably be the easier way, and then faces. And we'll do the same for this one. Need to zoom in a bit to get the axis. And then the face. And we'll apply and we'll cancel. And now we just need to do the 2 more bearings for the front bearings. This one's going to be between 8 and 8 because we know the size we want. We'll search for all bearing categories. I'll just try something different. I'll try an ISO 104 bearing for this one. And we'll position one there, and then we'll copy that one. So we've got 2 of them, and then we'll just constrain those. The face as well. Okay, so our shafts are a little bit short, a little bit small in diameter to do the parallel splines, although I will show you at the end. I'll just amend this drawing to show you what that looks like and how easy it is to do those parallel splines. But the next part, what we'll do is we'll draw a case, a very, very simple case, and I'll show you how to do that. So first of all, we want to check our origins and see where our origin planes are. And it's most probably going to be better to actually start our own plane somewhere. So we want our case so we want to start on the outside of that bearing. So I'll put a plane on that bearing surface there, so that we'll start the drawing here and we'll work from there. So we're going to create a case, and we'll just keep our gears saved in the same place in the file location. Click OK, and then we're just going to select the plane that we want to start working on. I am going to rotate round because I'm going to want some of the geometry to bring through the geometry. So I'm now going to start a two-dimensional sketch on that plane that we've just started. I'll do a bit of a rotation round, and I'm going to start by projecting a couple of bits of geometry, which will be the outside edge of our two bearings. There. And I'll just draw a very, very simple box arrangement. Something like that. Finish the sketch, and then we'll extrude it. Spin around so I can see it better. Lost my orientation for a minute. And we'll extrude it to this face of the other bearing. We'll click OK, and then we'll return, and we've got this block that we can, if I just go back and edit, sorry I missed out on doing that, so if I click back on the case and then edit it and shell it out and shell the various surfaces, we'll set it as a thickness of 5 mil, maybe a little bit less. Thickness of the bearing I'm going for. Looks about right. Click OK, and then return, and there we have our gears, shaft, bearings, keyways. All of those are already put in there, so we just now need to make it work. So really not much left to do now. All we need to do is we've grounded the case, so ground the case, unground the spur gears, and then make the spur gears flexible, and then you should find that you can rotate the actual spur gear, and the shaft is also rotating with it. So there we have our design accelerator. Now I'll just show you how we can go back and edit some of these as well, so that we can, for instance, put a keyway on the end of it. So the diameter of the input and output shaft have to be a lot bigger for the keyways, in our design accelerator, for our parallel splines to work. So if we come back to, I'm just going to edit shaft 1, so I'm going to right click, edit using design accelerator, and I know that I'm going to need to be upwards of 30 odd mil, so I'm going to just double click, and I'll try 30 mil as our input diameter size. Click OK, and click OK again, and we've now got this massive input diameter size. If I then go to the design accelerator and choose parallel splines, if I then just use my reference geometry of the actual shaft and the end of the shaft, you can see that we have now, the design accelerator has given us the opportunity to put the parallel splines on it. In our select objects to generate, it can generate the not just the cutout, but it's also can if it was going into something and you'd already generated it, it could already generate the opposite version. We don't want that. We just want the cutaway, so we can deselect the actual cut into, the actual extrusion of. When we just click OK and then click OK again, it will generate our spline shaft. But the problem is that it's very dependent on size, and as you can see, it needs to be fairly sizable input shaft to get these design accelerators to work. So I'm going to delete that design accelerator, click OK, and then I'll just go back into my shaft, right click on it, edit using design accelerator. We've got a conflict, but we knew sort of that was going on, so I'll just put that back down to 10 mil, and we'll click OK and then OK again, and there we go, we're back to square one. So that was a good introduction to design accelerators of the power transmission. They can be used for all sorts of different things, and it might make your designing process a little bit easier. On the face, it does look more complicated than just trying to design it all, but actually when you start to get used to it, it does make things a lot more efficient. So thanks for watching this Inventor tutorial, and I'll see you again soon for another tutorial.